Good afternoon. This video will review the rules of using exponents to simplify monomial expressions. To go over these rules first may be a good idea. So let's go ahead and start with that. So if I have two like bases, x and x, one is raised to the exponent of a, one has the exponent of b, the rule is we add the exponents and the base stays the same. So x to the a plus b. To go along with that, we'll talk about division. If I have x to the a times x to the b, we know that division is opposite of multiplication, so it makes sense that it would be x to the a minus b, where the exponent in the numerator subtracts the exponent in the denominator. So those are our first two rules. The next rule has to do with negative exponents in the numerator. So if I have x to the negative a, I always want to write my exponents in the positive. So I would write it over 1 and have x to the a in the bottom, and then you can see there's a sign change as this base moves across the division bar. This next rule is very similar to this one. It's where I have a negative exponent in the denominator. So x to the negative a. To make this exponent positive, I move the base from the denominator to the numerator, and then you can see that the base or the exponent becomes positive. Our next rule is a power rule. If I have a base to an exponent raised to an exponent, the rule here is that they multiply the two exponents together. And the other rule is x to the first power is the same as x, and our last rule is x to the 0 power equals 1. So those are the various rules that we use to simplify monomials with exponents. So let's just take a minute here. Let me erase this, and we'll go ahead and start with our two problems. Okay, looking at this problem, we can see that we've got two monomial factors. We've got some with negative exponents, some with positive exponents. And remember, the 3 right here actually has a positive exponent of 1. What you've got to realize is that everything here is written in the numerator. So anything that has a negative exponent to it is going to be moved into the denominator, and then we'll go ahead and simplify our problem. So let's go ahead and draw a division bar so we can start splitting this stuff up. 3 to the first, the 1 is a positive exponent, so it stays. If I look at 5 squared, that has a positive exponent, so it stays in the numerator. If I look at x to the negative 3, it has a negative exponent, so to make that exponent positive, this is found in the numerator, so I will move it to the denominator. Let's go over here and look at our other x. It's also negative in the numerator, so I will move it to the denominator, and then it will make it positive. Let's look at our y squared. It's positive, so it stays where it's at. If I look at this y, it's negative, so it has to move to the denominator. And so now that's simplified so far, so now I'm ready to finish the simplification of this. So let's look at the 3 to the first power is 3. 5 squared is 25. If I look at x to the third times x to the third, let me finish that piece there. So x to the third times x to the third, that add the exponents because we're multiplying like bases. That should be x to the 6th. And then if I look at y squared divided by y squared. I use the division rule so that we subtract the exponents. That gives me y to the 0 power, which we know is 1. So now for my final answer, I'll put all these pieces together. So I've got 75, and the y simplifies to 1, so it vanishes. And then for my denominator, I have x to the 6. So that's your final answer there. So just remember the rules. You want to rewrite it to where everything's positive, and then use the other rules, like the multiplication and division of like bases, to finish simplifying your answer. So now we'll move on to our next problem. As you notice that this problem is a power raised to a power. So the power rule states that if I have a base raised to a power then what I have to do is I have to multiply the exponents together. So in other words, a negative 1 times this negative 2 will give me that new exponent that belongs to the 3. So let's go ahead. That's the rule that we're going to use to start this. And we're going to remove the parentheses by using the power rule, and then we'll apply our other rules that we used in the previous problem to finish this problem. Let's draw our division bar. So a negative 2 times a negative 1. That'll make it a positive 2 exponent on the 3. A negative 3 times a negative 2. That makes that a positive 6 exponent on the m. The n. 4 times a negative 2 gives me a negative 8. And then I've got negative 1 times a negative 2 will give me a positive 2 on the 6. Now remember, the m has a 1 on it, this m. So 1 times a negative 2 gives me m to the negative 2. And then lastly, I have an n that has a negative 2. So a negative 2 times a negative 2 gives me a positive 4. Okay, now we've got it that far. The next thing that we want to use is use our rule of negative exponents in the numerator and the denominator to move things around to where all of our signs on our exponents are positive. This is already positive, so it stays where it's at. So we know that 3 squared is 9. This stays where it's at, so 6 squared is 36. Now I've got m to the 6th. It stays where it's at because it's positive. The exponent is positive. Now m to the negative 2, that exponent is negative, so it has to go up here. So that'll give me m to the positive 2. Now if I look at my n to the negative 8, to make it positive it has to come down below. So that'll be n to the 8th. And then the n to the 4th is already positive, so it'll stay right where it's at. So now I've got everything written as positive exponents. Now I'm ready to simplify. So 9 over 36 is the same as 1 over 4. M to the 6th times n to the 2nd. This is the multiplication rule. So I can add them together and get m to the 8th. Multiplying of like bases. Down here I have n to the 8th and n to the 4th. So I can add the exponents together and get n to the 12th. So that is my final answer for this one. So you could write it as 1m to the 8th over n to the 12th, or you could write it as m to the 8th over 4 n to the 12th. Either way is fine. So those are the rules for using exponents into simplifying monomial expressions. Be sure to do your homework, and if you have any questions, come in. I'll be glad to answer. And make sure you have a happy day and have happy homework. Thank you.